I'm looking forward to talking about Windows and how Rundeck interacts with it today. I will say before I get started that there is a lot we could have covered today, and frankly, we wouldn't have enough time to cover everything and do it justice. So I picked the things that have come up most often for our customers in talking with both customer support and our customer success team. But if there are things we didn't cover that are related to Windows that you have questions on, we'll do our best to address those questions in the Q&A at the end, or if necessary, we'll take those offline and address them with you individually afterwards. All right, I am going to turn off my camera so you don't have to be distracted by the bridge in the background through the whole thing. All right, so our topic today is using Rundeck with Windows. Our general agenda, first I'm going to talk about some considerations around clustering. This is where I think the most significant decisions might need to be made, and so I want to talk about the implications of some of those decisions. We'll talk about the 3 plugins that you can use when connecting to Windows nodes, talk a bit about configuring WinRM, which you'd need for any of those 3 plugins, and then spend some time talking about installing Rundeck on a Windows server. So you could do 3 different things in general if you have a cluster. You could have an all Windows cluster. That's the likely case if you have an all Windows node environment, but it also might be the case if you have mixed nodes, some Windows and some Linux, but your team's expertise is primarily with Windows. You could also do an all Linux cluster. That's likely the case if you have an all Linux node environment, but also might be the right choice if you have mixed nodes or even all Windows nodes, but your expertise is primarily with Linux. The last choice is the mixed platform cluster. On the surface, this seems like it's the right choice if you have a mixed node environment and you have teams that have expertise with both Windows and Linux. But it's probably the most complicated choice. Some of the ways that projects are configured don't necessarily lend themselves well to a mixed platform cluster. So you can definitely do this, and we've worked with customers that have used this mode. But if you do, you need to consider segregating by platform, having Windows-specific projects and or Linux-specific projects, and making sure that those project jobs are executed on the appropriate platform, which is all doable, but there's more overhead and initial setup to get that to work. And if you set up new projects and don't keep that in mind, you'll have undesired results. So if you're going to connect to your nodes from a Windows server or cluster, the basic choice is, do you want to use WinRM or SSH? You can use WinRM to connect to your Windows nodes. And if you're using WinRM, there's 3 plugins that are possible. The 2 likeliest that you'd use are the PowerShell plugin if you are an enterprise user, and that's strictly usable if you're on a Windows server. Or you can use the Python WinRM plugin from a Windows server as well, and that'll let you connect to those nodes. Alternatively, you could use SSH to connect to all your nodes, whether they're Windows or Linux. So it's more set up for the Windows nodes, which may or may not have SSH enabled, but using one of the SSH plugins would allow you to be somewhat platform agnostic in terms of your connectivity. You'd use the same connection mode effectively, whether or not you're connecting to Windows or Linux. For your Linux nodes, obviously you can't use WinRM. There are a number of choices that are fairly specific depending on your environment, but in general, most customers will use one of the SSH plugins more often than not. So again, if you use SSH kind of across the board, you'd simplify your connectivity, although using WinRM gives you some native functionality that you might not get with SSH. If you're connecting to nodes from a Linux server, for your Windows nodes, you wouldn't be able to use the PowerShell plugin, but you could use either of the other WinRM plugins. The preferred plugin is probably the Python WinRM plugin. And alternatively, you could use the WinRM plugin, which uses the over-there libraries. Again, you'd have the option to use SSH for Windows as well as for Linux. So when you get to the mixed platform cluster, you're going to have to make some choices. Effectively, the choices are about the node executors and your node resources. In terms of the node executors, if you use SSH as your node executor, then you're in a position where you might still have platform-specific projects, but you don't necessarily need to be concerned about which server runs those jobs, because you can SSH from either Windows or Linux without a problem. If you use the PowerShell plugin, which means you're connecting specifically from a Windows server, if that's your node executor for a project, then by definition, that project must always run from a Windows server, which means you're going to need to set up remote execution policies and probably auto takeover policies to ensure that those jobs are always handled by one of your Windows cluster members in your cluster. So that's where that starts to get complicated. And the other piece is the node resource data. If you have your node data stored in a file, which isn't the most common case, but certainly is common enough, that gets complicated with a mixed platform cluster, because as part of your project definition, you're going to point it to a path where that file exists. And the path is going to be different from Windows to Linux. So you need to make sure that your node resources are somewhere that's system agnostic. You could be pointing to a CMDB, but you want to point to something where all the servers, regardless of platform, that are in the cluster can refer to that data in the same way. And then you avoid the complexities that you might otherwise have. So those, I think there probably are other issues that may come up in a mixed platform cluster, but these are the two main ones. So the question that really comes up, if you haven't already deployed, is should you deploy a cluster that's single platform, or should you do one that's mixed platform? You can probably guess that my answer is going to be single platform. Even if you have a mixed platform set of nodes, you're probably going to do yourself a service by choosing either Windows or Linux so that your servers are consistent, and that's going to simplify setup, administration, and overhead over time. It's not that necessarily mixed platform is impossible to support. As I said, we have customers who do it and it works fine, but having set up several customers as single platform clusters in this sort of environment, and some as mixed platform as well, the single platform definitely produces fewer headaches. So if you can choose to do it, pick single platform and pick whatever platform you're most comfortable with. Regardless of what your nodes are, if your team is more comfortable working in Linux, then set up some Linux cluster members. If you're more comfortable in Windows, set up some Windows cluster members. And then you'll look at your your choices for node executors based on that, and obviously what your nodes are. But that would be the general recommendation, I think, is do a single platform cluster if you can. And if you have to do a mixed platform cluster, just bear in mind those couple of issues that that will be challenges for you. So the next topic is just talking about the plugins that you can use for connecting to Windows nodes. There's 3 choices, and mainly I wanted to break out what the differences are, at least on the surface. I don't think there's an easy way to see these differences anywhere that I found in our documentation, so I thought I'd call them out to make them as clear as we can. So the 3 plugins are along the left side. WinRM, which is the oldest of the 3. It's also known as the Over There plugin because it uses the Over There libraries. WinRM Node Executor Python, otherwise known as PyWinRM, and the PowerShell Node Executor, which is one that you'd have if you're an enterprise customer. So in terms of differences, the PowerShell plugin, the enterprise plugin, works only on a Windows Rundeck server. Obviously, they all connect to Windows nodes, but server side, that one is Windows only. So that's one element you need to keep in mind, depending on how you're setting up your cluster. All 3 of them use NTLM, the most basic authentication protocol. The Python and PowerShell plugins use CRED SSP. Currently, the original WinRM and PowerShell plugins have Kerberos, but the Python one will have the Kerberos support here soon, which is why it has an asterisk. And Negotiate as a protocol is supported by the PowerShell plugin. So in terms of the protocols you could use, the PowerShell plugin offers you the broadest set of choices. That may change over time. It's possible the Python one will add additional features, but today that's what the options are that you have. The other difference that seemed worth pointing out is what shell environment you can use with the different plugins. The WinRM plugin, I believe, only offers you the CMD shell, which is your standard shell. The Python WinRM be either CMD or a PowerShell shell, and the PowerShell one uses PowerShell. So again, depending on what you need, you might find one or another of these more appropriate for what you're looking at. Before I move off of here, I think in general, from the perspective of our support team, if you're an open source user, we would probably recommend the Python plugin as the most appropriate one to use. If you're an enterprise user, assuming you have Windows servers in your cluster, the PowerShell plugin would be the one that's recommended, with Python being the next choice. The original WinRM plugin has some limited options, as you can see, and is the oldest in terms of when it's been updated and all that. So it's probably the 3rd choice or last choice, regardless of which environment you're working in. So I wanted to talk a bit about configuring machines for WinRM. So all 3 of the plugins I just talked about are using WinRM as the underlying protocol. So whether they say WinRM in the name, the PowerShell one doesn't, but it really does use WinRM. That's the native protocol for this sort of thing in Windows. But WinRM needs to be configured probably in some way on every machine in order to have it configured in the right way. And the likely way you're going to do that is using PowerShell commands on those machines. So these are some example commands that would be relevant on nodes that you're going to connect to. The first command, WinRM does a quick config. The quick config applies basic settings, and in some cases might be enough, but in honestly all the cases where I've worked on it, even though I'm in a demo environment as opposed to a real world environment, I've needed to go ahead and add some other commands to enable other features. But start with the WinRM, and it might be worth running that WinRM again at the end. I've seen some notations as I've looked at different articles online that say some settings that you might otherwise set will get cleaned up a bit by rerunning that quick config. So just something to keep in mind. The second command essentially is going to turn on HTTPS as a listener so that you can have secure HTTPS connections to that node. There may be other pieces you need to turn on, but that's turning on the basic transport. The next set of commands are ones that turn on basic authentication and unencrypted messages. Obviously, this is not what you want to do in a production environment, but if you're in a test environment and want to enable the basic connectivity to see how it's working before you lock it down further, these are commands that would work well in that scenario. And I didn't call out every possible option here because frankly there are a lot of options depending on which authentication you're using and how you're setting it up. So I just wasn't going to be able to cover everything that someone might use. The next one is probably one you'll need, and it is setting it up to commit memory for commands that come in through WinRM. By default, I forget what the amount of memory is, but it's not very helpful if you're doing anything of consequence. So it's likely you'll need to run that command. And then the last one is more just a nice to know command. You can do a WinRM get WinRM/config, and that'll give you all of the WinRM settings. If you add the -f:pretty, it puts it in a little bit more human readable form. So those are all ones that are node side. There are some settings that seem roughly the same, but are a bit different in the command. They're doing the same thing, but from the server side versus the client side. So be careful to make sure you're getting the right command for either client or server. So next I've got some of the commands that are server side. And the notes I've seen say you may not need to do anything on the server side. So far in my experience, I always have, but it probably depends on the settings that are laid down on your servers. So your mileage may vary. If you need to do commands, again, the WinRM is one. The WinRM set trusted hosts basically allows anything to be a trusted host, and obviously there'd be other ways to specify which trusted hosts you want to allow, and the comparable command on the server side to turn on unencrypted messages if you're going to use things in an unencrypted mode for your testing. All right, I think that's it for WinRM stuff at the moment. Oh, yeah, there's one error we've seen come up several times recently that I wanted to call out. There is a 500 error. We'll see the how the error manifests itself here. It is a WinRM error, and WinRM isn't particularly helpful in this case, but what the WinRM error in this case is saying is that the connection has timed out. I believe the only cases we've seen this have been in the WinRM, the original WinRM plugin, in which case you'll want to fix it by changing one or both of these settings. The default for the bottom one is 15 seconds, which is expressed as 15,000. In the top one, it's set for 60 seconds, a full minute. The values I've entered here basically make it 5 minutes, which one would hope is reasonable. But think about how long some of your jobs run that might run on your Windows nodes, and set your timeout appropriately. You don't want the job to end early because the WinRM timed out before your job was finished. You can also set a max timeout setting in using a WinRM command here, but I think effectively these settings in the WinRM plugin do the same thing. I think they're setting that same value. So I think it's easier to do it in the GUI, but I included the command in case that is helpful to anybody. The last section here is talking about installing Rundeck on a Windows server. I'm not going to go into all the details. We've done it before, and frankly, it's a lot of command lines and config files. But I did want to talk about the high-level details. The first thing, obviously, is provision a server. Might be virtual, might be physical. Mostly these days, it's virtual. In my own personal experience, I'd say you want to have at least 8 gigs of RAM. I know our minimum in our system requirements is 4 gigabytes, but with Windows, it seems like Windows is a bit of a RAM hog. So I'd start with a little bit higher amount, and you'll have better performance. Download and install Java. It needs to be Java 8, and then download Rundeck, the WAR file, since that's what you're going to use with the Windows install. Then create or choose a root directory. You want to have a distinct directory. I usually use C: Rundeck, but it doesn't matter as long as you know what it is. Put your WAR file in that directory, and then you'll use it a little later in the process. You're going to set an environment variable called RDEC base, and then you're going to go into RDEC base, but RDEC base is going to be that directory you created, and then you're going to run the command to start using that jar file. And obviously the name of your jar file will differ. Once you stop it and do a bit more work to configure things to make it more maintainable over time. So you're going to create a batch file. That batch file is going to refer to a profile file, and it's this bat file that's going to really start things, but we'll have a service call it. So we want to edit the memory settings in the profile.bat, which is a file that will be there automatically underneath your RDEC base. These are the values you want to update, and this is already updated, I think, from what the default is. As a general rule, you probably want to set the system to use something like half of the available memory that your system has. But this is the minimum and this is the maximum value that you're providing in terms of memory. You're going to create a Rundeck service, and there might be a few different ways to do this. In our documentation, we suggest you can use a tool called NSSM that makes it pretty easy to create a service, and that service calls the batch file. The reason we want to create a service, obviously, is that's going to automate restarting Rundeck when you restart the server, and makes it easy for you to have a graphical way that you can go in and stop and start and do those sorts of things. So this is optional, but it does make it, I think, handy to work with. Then you want to do your configuration in your framework.properties and your Rundeck config.properties. That's all pretty familiar to you guys, but obviously just making sure that you've specified the name and port and HTTP or HTTPS as needed. And lastly, go ahead and and start Rundeck using that services console.